So far in these tutorials, you've used blocks of code called functions, perhaps without knowing it. For example, when we typed len followed by a list, such as x, it returned the number of elements in that list. The command len is one of the built-in functions of Python, meaning that these functions are available by default every time you open a Python shell. Another such function is pow, which raises one number to the power of another. For example, typing pow 10, 2 returns the value of 10 raised to the power of 2, or 100. We can see that a function has the following characteristics: the name of the function followed by parentheses, and then usually one or more inputs with each input separated by a comma. These inputs are called arguments, and usually the function specifies how many arguments it can take. Some functions require an exact number of arguments, while others may only require 1 or 2, and still others might not need any arguments at all. For example, we can learn more about the pow function and its arguments by typing help pow. This function requires at least 2 arguments, the base and the exponent represented here by base and exp. If you enter 2 numbers, the function will raise the first number by the power of the second number, as we just saw. However, you can also explicitly specify which number belongs to which argument by using the variable names specified in the output from the help file. For example, pow 2, 10 would return 2 to the power of 10, or 1024, while pow exp equals 2, base equals 10 would return 10 to the power of 2, or 100. In the latter case, when the arguments are assigned to the appropriate variable, the order of the arguments doesn't matter. Now that you've seen how functions work, you probably want to create your own. Let's begin by replicating the pow function by calling it something else. We begin by using the def, or definition keyword, followed by the name of our function, and then a colon. This is similar to the pow function above, with the body of the function containing a return keyword, followed by a mathematical formula that raises the base to the exponent, symbolized by 2 asterisks. Return in this case means to return some value after the function is run, which can then be used by other code later on in the script. Once you have defined this function, try running it with some parameters, for example, myPower function 10, 2. When we used the help function earlier, you may have noticed that it outputs some text explaining how to use the function. We can include this explanatory text by using 3 sets of double quotes, which indicate that the text is not to be run as code, but simply to be read by the user. Here I'm including explanatory text explaining what exactly this function is, and then an example of how to use it. Once you've included the help file, you can return it by typing help followed by the function name that you just created, which will return the documentation we just typed. In addition to the built-in functions, Python also contains a library of modules that can be accessed using the import command. Within Python, modules can contain other functions, along with the code and variables needed for the function to run. In order to see all of the modules that you can import, type help and then single quotes modules, which will return a list of hundreds of modules within Python's library, and there are a lot of them. For example, you might see a module called random, which if we type help followed by the function name, which is random, we learn that it is a random number generator. There are several methods that are part of this module, which you can see in the documentation, which is quite extensive, which act like functions that are bound to a specific module. Reading through the help file, we see that there is a randint method that we can use to generate a random number between and including 2 numbers. To import the random module along with its methods and functions, we would type import random. And then we could run the randint method by using something called dot notation, which indicates that the method is being executed as part of a module. For example, random.randint and in parentheses 1, 10. Running this code will generate a random number between and including 1 and 10, and running the same line of code repeatedly can produce different results. If we want this method in particular from the random module and nothing else, we could type from random import randint. Lastly, you may choose to create what's called an alias for the modules or methods that you import, which is just a shorthand version for convenience. You often see this in code for Nylon, for example. With our current example, we could substitute rand for the module name of random. Using this code, import random as rand, and then execute the randint method using rand.randint followed by whatever arguments you want. Alternatively, we could import the randint method itself with an alias. From random, import randint as ri, and then use ri as the function. Note how the keywords from and as are used to specify which module or method will be imported under which alias. The name of the alias is arbitrary, but make sure it doesn't conflict with any other keywords in the Python library. Functions and modules greatly expand the range of what you can do in Python. Although Python has many built-in functions and modules, the amount that you can import is essentially endless, and there are other ones you can download either using pip or by downloading additional modules through GitHub, which programmers are always updating. This will be necessary for using the more advanced neuroimaging packages that we will learn about later.